There's a trend in equipment manufacturing to take relay logic components, miniaturize them, and solder them onto circuit boards. Relay logic is where you have discrete electrical components like switches, relays, timers, and contactors that are wired together to create some type of control circuit. You can take inputs from buttons, pressure sensors, thermometers, or photo eyes and perform sophisticated Boolean logic operations like NAND and NOR simply using interlock switches and a series of relays. Both historic and modern equipment use a variety of creative alternatives to printed circuit boards to achieve automation and controls, including camshafts in screw-cutting lathes, punch cards in pattern-making looms, and centrifugal governors used in steam equipment. But the versatility of relay logic has seen its proliferation in applications as diverse as the control of ignition sequencing in home furnaces, to the control cabinets that use large banks of relays to control the sequencing of industrial robotics within factories. Many of us have experienced bewilderment at the addition of Bluetooth-enabled touchscreen bot-farmable control boards to home appliances that had previously functioned just fine using relay logic. A couple of forces have been contributing to this trend: the abundance of cheap Chinese labor, the proliferation of pick-and-place machines for the automated manufacturing of printed circuit boards, a desire to appear more modern and advanced, and a push for more miniaturization have all helped to push circuit boards into places where they don't really need to be. As long as it's cheap, this fad isn't necessarily bad until someone tries to save money by integrating high voltage or high amperage components onto a circuit board. This is where we get the boomer complaint that new appliances don't last as long as appliances did back in their day. Parts like the contactor that sends 230 volts to the heater in an electric dryer, or a control transformer that converts 120 volts to 24 or 10 volts, need to cool. If you solder these components onto a circuit board and dip them in the protective epoxy that is standard on appliance boards, they aren't going to cool as well as if they were mounted on metal and not dipped in epoxy. Overheating components is one of the primary failure modes of most modern appliances, and if they overheat on a circuit board, they're going to destroy the circuit board. If manufacturers stopped making this one mistake, most new appliances would last longer than old appliances. Inside industrial control cabinets, small microcomputers called programmable logic controllers are used to replace low-voltage logic circuits, but high-voltage components are left separate. This removes the pressure to make high-voltage components artificially small, enables them to cool properly, and makes service in the event of a failure immensely faster and cheaper. I fix welding equipment at my day job, and I encounter a lot of high-voltage components like rectifiers, capacitors, and relays that have been soldered onto circuit boards. They blow pretty frequently, and the boards can cost upwards of $3,000. The physical separation of current-carrying circuitry from control circuitry has been a well-established design principle for a long time, and anyone involved in any type of equipment design should be familiar with it.